Hello, my name is Robin Mitchell, and today Electropages is here at Embedded World in Nuremberg. And today I am joined by...
Yeah, thank you, Robin. My name is Miro Adzan. I'm responsible for the ADAS activities at TI. System engineering, so basically focusing on how we can actually position the right products into the advanced driver systems.
And
thank you for coming.
And today you're going to show us some different products that you're announcing.
Exactly. So we'll show you a little bit about the demos that we have on the show, and specifically on some new products that we're announcing for the vision analysis, including artificial intelligence capabilities and accelerators. And it's a broad portfolio that is scalable for the different requirements across the different number of cameras.
Fantastic. Well, let's take a look at what you've got on show and see how it works.
Absolutely. Thank you.
So, what's going on down here then?
Yeah. So this is a new portfolio of products in the ARM processor space. This is of interest because this offers the opportunity for our customers to have a scalable platform of ARM cores. What we have here is the AM62A platform, and these devices of this overall platform is actually for the smaller number of cameras that you want to process. All these processors are dedicated for vision analysis, including artificial intelligence as well as machine learning capabilities. Starting with the AM62A, this one is a system that supports 1 to 2 cameras that you can connect. And then moving across the different products in this family, you can actually go to up to 12 different cameras that you can connect.
Brilliant.
So why is this of interest? This is of interest because it is a very low power consuming system. We talk about implementations of 2 watt and less.
Yeah.
So this can be used for doorbells, but it can definitely also be used in the automotive space for driver monitoring cameras, as well as for systems where you actually have the image taken and then analyzed by artificial intelligence.
So, if I'm correct, this is a development board for the products?
Correct.
And this here is what we're talking about?
Correct. Yeah. So basically, not only do we support the hardware in terms of the chips itself, but this comes with a broad set of different development kits, SDKs, libraries, and we also, as you can see here, we have also some of our third parties that are also supporting the development libraries and the systems. Yeah. And the other interesting thing is that we're talking here about an ARM Cortex 52, as well as a 53 and a 72 ARM Cortex, depending on how much processing capabilities you're requiring. And again, these devices can be used in the industrial space, but we also have solutions and options of the parts that go into the automotive qualified requirements.
Now, as we go across the different products, are we saying that this is all like a scalable solution?
Yes, exactly. So it is scalable in terms of the number of tops, so basically how many instructions you can process, and then you can reuse the different software pieces that you have developed from one core to the next, from one platform, from one component to the next, in order to make it easy for our customers to have the scalability not only on the hardware, but also on the software.
So let's go ahead to the next section to see how this thing scales up.
Absolutely.
So this is the second section that you wanted to show us about the scalability of this product.
Yeah, absolutely. As we saw on the first one, the AM62A is a device that supports up to 2 cameras. Now here we're moving to the next level of the product. Now the AM68A, this is the device that goes from 1 to 8 cameras. So depending on what kind of applications you have, you can now integrate and fuse the information from the different cameras into one artificial intelligence supported algorithm that is then analyzing the camera feed.
So does that help with things like depth perception?
It definitely does help with the depth perception, but it also helps with getting a different angle for the object that you're looking at.
So you might have like lots of cameras in kind of like an angle or something, so you can get different perspectives.
Exactly. So think about one of the applications, as we see here in the top part, is you have a robot that is going through the logistic warehouse. Now, in order to make sure that you can identify the different people that are crossing or the different other machines that are crossing the path, you need to have the vision not only from one camera, but potentially also from other areas. And with this, you can then actually make a picture of the environment that is much better suited to guide the robot through the warehouse.
Oh, so I was going to say that robot had like cameras in different angles, like backwards, forwards, left and right.
Potentially, yes. Yeah. It can also be on the robot itself, so it can see on the left and the right and in the back if something is actually going to overtake, and then it can slow down the robot. But what you can also see is that with this system on chip, we are also able to run algorithms to identify the individual objects in the pictures and then classify, cluster, and then use this information for identifying, okay, is this a moving object? Is this a stable object? Is this a dangerous object like a car or something else? Or is it just something that is lying on the ground?
Brilliant. Now, are these systems or modules that integrate the TI chip?
So, yes, so what we have here is, obviously we have the development kits that we are offering also for our customers, but then we have third parties that are also developing their systems and their SoCs, their chip-on modules, in order to implement this into different industrial and automotive applications.
And in this case, that's the TI part there.
Exactly.
Yeah.
Exactly.
Brilliant.
Yeah. And then, of course, you have memory, you have interfaces, you have the power supply, everything that comes along that is actually needed in order to drive the overall system.
So customers can either go for the chip itself and design their own solution, or they can go for a third-party module, which might help it, will make it easier to integrate this part into their own project.
Exactly. Absolutely.
Brilliant.
And we are also supporting with libraries. So in the SDK, in the software development kit, not only you can actually work on the hardware, but you also get demo code with your SDK. And with this, it's easier for you to implement different implementations.
Now, I take it the part number is the AM68A.
Correct.
And in the other side, we had AM62A.
Correct.
So is this different silicon for each one? But
So yes,
it's modularized.
yes. So it's different silicon, but obviously it's reusing IP, and it also makes it easy for our customers to reuse the software that they're developing.
So it increases on the number of cores and it increases
Exactly.
the peripheral count. But it's kind of like the same, but not the same. But you're kind of like making it bigger.
Exactly. Yeah.
Brilliant.
So basically, if you have fewer cores on the smaller ones, and you have more cores here, and you get an additional processing capabilities. As you see here, you have 8 tops.
Yeah.
So Terra operations, whereas here you have 2 tops. And then going to the next...
AM69A, yeah.
Exactly. Going to the next member, you then actually have an even higher processing capability.
And by having this scalability, you can use the same SDK and the same training models on all of those devices.
Absolutely.
Because you can move across to different families.
Absolutely.
Because the fundamental hardware is kind of the same, because it works in the same way.
Absolutely. So think about it that you can develop your software once, and then depending on how sophisticated you are advancing in your software development, you can port the software from one platform to the next and stay in this scalable portfolio, making it much easier for you to actually have different implementations.
So you might start a project on the AM628, but then you realize you need more cameras, so you go up one, but the software will still carry over.
That is correct.
Brilliant.
That is correct.
That's brilliant.
And this saves a lot of software development time.
Yeah.
And it also makes it easy for you to optimize the software, because you're moving through your different projects and you're reusing and optimizing the software. And then you actually get additional resources in terms of processing, interfaces, and so on, that you can then use to have more sophisticated implementations.
Fantastic, fantastic. And so now we've got the third part of the scalability solution here, happy with the AM698.
Yes. So what we show here, this is the third member of this family. Obviously, we have also other family members, but for our display, we have here the AM69A. Now here we have the higher processing capabilities.
Yeah.
So now we talk about 32 tops that you actually get with the hardware.
That is significantly bigger than the previous one.
Absolutely.
Wow.
Absolutely. Yeah. I mean, of course, you need more cores, you need more interfaces, you need a different power solution. Here we can actually process up to 12 camera feeds.
Yeah.
Now, when you think about applications, starting with the AM628, this is a 1 to 2 camera implementation. Thinking from an automotive world, this would be a driver monitoring system, for example. You have basically the camera that is taking the picture of the driver to ensure that there's no drowsiness, no attention, and this information is then actually processed on the chip itself.
And so you're not just being aware of your environment, you're being aware of the driver and the internal environment.
Exactly.
Because the driver is just as much of a risk to other drivers as the car itself.
Absolutely. This is basically in a driver monitoring system. And here you can actually live with 1 to 2 cameras.
Yeah.
Now, as you move to different applications, this example here, as said, 12 cameras. Now you can actually equip a robot, a logistical robot, that is driving through your warehouse and having the cameras around the robot to ensure that nobody bumps into the robot, or that the robot does not bump into something else. And since this is real-time processing, you need a higher processing capability on your chip in order to process the object or the data that comes from the camera, classify the data, characterize the data, and then decide, is this a dangerous object or is this not a dangerous object?
And so just like before, we've also got third-party boards that take your chip and modularize it so that it's easy for engineers to use again.
Exactly. Yeah. So it makes it easy for our customers, depending on where their expertise is and where they actually want to focus their development activities in. They can go with some of our partners using hardware system modules, or they can go with the chip itself and then develop everything by themselves. They can leverage the software that comes with the SDK, and they can also benefit from, in these cases, from a very low power consumption, starting with a 2-watt power consumption, going to higher performances with higher power consumption, but depending on how close they make their system and how much processing power they require, they can scale across the different use cases.
And so the increased processing power, the increased energy usage would make this more suitable for things like EVs and self-driving vehicles.
Potentially, yes. Yeah. So potentially now we need to see what kind of implementation you want to have, what kind of use case, but these are devices that are supporting the autonomous driving, the intelligent driving, and this can be in the industrial space and can also be in the automotive space. That's why we actually offer the devices also with automotive grade and with a standard industrial grade.
And is this development board here, is this one specifically manufactured by TI?
So TI does not manufacture PCB. We do not manufacture boards, but this is something that the development kits are offered through TI. So if our customers want to add a development kit, SDKs is easy. Download this from the website, but then you can also order our evaluation boards, our development kits directly from the TI website.
So you do have evaluation boards that TI themselves have designed?
Yes, and then they can actually order this from TI, and they can very quickly start with their development activities.
Brilliant. So you've got a new microcontroller board coming out, is that right?
Absolutely. So what we saw before is actually the higher end microprocessors, basically system on chips, where you actually have really a lot of processing power. But very often you also require something that is smaller in terms of the microcontroller housekeeping functionality, maybe something that is only driving a small motor in the car or somewhere else, a small electric motor. And sometimes you need something that has a very high set of analog components for sensors. So basically measuring current, measuring voltage, measuring temperature. And what we are introducing here is a ARM Core M0 Plus, basically entry-level microcontrollers, entry-level microcontrollers, very cheap or very cost-effective, with a set of scalable analog interfaces. And when I say analog interfaces, I'm talking about A to D converters. So basically now on the microcontroller, you have a 12-bit microcontroller, a microcontroller with a 12-bit A to D converter, where you're actually taking and sampling analog signals and then process this in here. This is a set of products that is not only 2 or 3 microcontrollers, but is actually a broad set of up to 100 different configurations of the microcontroller in order to help our customers to implement, dedicated to their needs, their solution. And again, this is a microcontroller from the M0 Plus class. And as you see, there's a very broad set of different configurations.
And so you've got scalability when you choose the product you want.
So again, scalability is one of the important things, and scalability in terms of the hardware, but also scalability in terms of the software, because again, you can actually reuse the software that you develop on smaller devices, also for higher performance
and so again,
controllers.
if you start a project with a smaller one and you go, actually, I think I need a more powerful one, you can basically swap over for a different chip, but the software will still port over.
Yes, absolutely. And what is nice here is that we are starting with a microcontroller of about 39 cents for 1,000 units. So it's really low in terms of the price.
39 cents?
Exactly, yeah. Obviously for 1,000 units, so if you have higher volumes,
that's still,
even go
still very cheap. That's 39 cents. That's really cheap for a high-end TI part as well.
Yeah, I would say maybe it's a high performance system for a microcontroller. But it is actually a very cost effective
it's a TI
device.
part, so it's really good value. So.
Absolutely. Yeah, it's a very cost effective solution, and it helps with housekeeping, but also with dedicated implementations, temperature sensors, driving motors, you name it, in the industrial as well as in the automotive world.
Brilliant. Now, I think I saw a demonstration over there with a camera, and is that also using a microcontroller to do?
So we also have a demonstration. This is not a microcontroller because this is again object detection, classification of video feed, and then actually we can see how the actual classification of objects is actually done.
So we can now go over to that stand to see how that one works.
Yes, let's do that.
Fantastic. So now we've come to the second demonstration, and this is where you're going to show me the object recognition system for another microcontroller, is that right?
Yeah. So this is actually now the next level of processing capability. So what we've seen the M0 Plus. That's a microcontroller housekeeping very, I would say, very dedicated and focused encapsulated functionality.
Right.
Then we've seen the AM62 family, which is actually the vision,
That's right.
the vision processors. This is the next level of performance. Now we're moving even higher in terms of processing capabilities and in terms of algorithm analysis of object detection. What we see here is a TDA4 based processor. That's also a multi-core processor that is now capable of taking additional information not only from the cameras, but also from the motor and driving the motor, an electric motor, as well as identifying the different objects in the picture. The application here is a industrial robot application, but it can also be used in automotive applications because the device is also automotive qualified. Now, what you can nicely see is that in the display on the right side here is that we have the object detection. That is, the software is running on the processor, on the ARM core, and is clustering the different objects that are seen in the cameras, and then already taking a identification of where the eyes are, where the arms are, and with this it's something that can be used for driver monitoring, can be used for autonomous car implementations, because you can now not only identify the object, but you can also identify in which direction is the person moving, where are the arms. And in this application, it's actually for a robot, where the robot can then actually identify the object, pick the object, and potentially also bypass any obstacles.
And so we've got a microcontroller that's reading a camera feed over USB.
So actually, it's a microprocessor. It's not a microcontroller.
So it's actually a microprocessor.
Exactly.
Oh, right.
So it's actually a next level of performance.
Oh, right.
And the camera feed can be done from different sources and with different interfaces. In some cases, as you see here, is also with USB, but the interface can also be a Ethernet interface connecting the camera. It can also be a direct connection of the image sensor that typically is a CSI2 interface.
Brilliant.
And then we also here have the capability to process on the processor, on the chip, the display information, and then drive the monitor and everything happening in this one chip.
And so this microprocessor is not only able to do things like it's not only able to classify objects in a video feed, it can also do things like motor controls and things like that as well.
Exactly.
So you're really combining everything you need in an industrial solution into one processor.
In this case, exactly. So now we actually have a much more performant solution, but it can also be used for different applications.
Automotives. So
yes, absolutely.
That's brilliant. So now we're looking at a microcontroller over here that I think you're saying controls motors as well?
Yes. So basically what we saw first with the TDA4 platform, that's a microprocessor that does the object detection, the video feed being analyzed in terms of what kind of objects are actually in the picture, and then also doing the different classification. Now the actual driving, the real-time drive of the motor is actually done with these microcontrollers, with the MPUs and MCUs that actually also are new from TI, and have a real-time control loop for the motor drive.
I was about to say, is that because microcontrollers tend to give you a better response in terms of real-time control? So if something suddenly changes in the motor current, a microprocessor can't respond as well as maybe a microcontroller.
Yes, exactly. So the microcontroller has a real-time capability.
Yeah.
So the control loop, which includes the current measurement, the voltage measurement, the position encoder, is actually done much more deterministic in the microcontroller, whereas the microprocessor has typically wait states and is actually not as deterministic as you will actually require for a real-time industrial motor control. Exactly.
And so would it be common for an engineer to combine these two products into the same system?
So, and that's what's happening here. We basically are combining the implementation for the microprocessor and the object detection of the video feed with the microcontroller that is driving the actual engine, the electric motor, and that can be used, for example, to implement a robot arm or any other industrial machinery.
Fantastic. So that was a fantastic demonstration of the new products that TI is showing. But I've got one question for the engineers who are watching this podcast. If they want to get involved with these new products, what would you recommend?
Thank you, Robin. Also appreciated the time and also the opportunity for us. So definitely, if you're interested in getting more details, go to the ti.com website. That's the best place. And we will also have some information in terms of the news releases for these specific products. But I would recommend the best way is actually go to ti.com and then search for the products and for the applications that you're looking for.
Brilliant. Thank you. Thank you for taking the time.
Great. Thanks.